In this video, we'll be graphing a rational function by hand using asymptotes and intercepts. So the function that we're going to graph is g of x equals x squared minus 4x minus 5 divided by x minus 3. First thing we're going to do is factor the numerator and denominator completely. So the numerator here factors into x minus 5 times x plus 1. So let's get that on our screen. Okay, here we are. So now that we have everything factored, we're going to first find our intercepts, beginning with the x-intercepts. So that means that we are setting our function g of x equal to 0, which, because this is a rational function, means that only the numerator will be equal to 0, so we'll set that equal to 0, which tells us that x is equal to 5, or x is equal to negative 1. So we have x-intercepts at 5, 0, and at negative 1, 0. So we can go ahead and plot those, 5, 0, negative 1, 0. Now we'll find our y-intercept, which occurs when x is 0, so we can find g of 0. So that means we're plugging in 0 for all of these x terms, which just leaves us with negative 5 over negative 3, or 5/3. That means we have a y-intercept at 0, 5/3. So that's a 0, 1 and 2/3. Well, that should be up a little bit higher, but we're just approximating anyway. Let's go on to our vertical asymptote. Vertical asymptotes occur when the function is undefined. So that means, in this case, when the denominator is 0. The denominator is 0 when x is equal to 3, so that's our vertical asymptote. So we'll go ahead and draw a dotted line at x equals 3, and this will help us to see the shape of our function. Now we'll look at horizontal asymptotes. The degree of the numerator here is 2, the degree of the denominator is 1. That means the degree of the numerator is larger than the degree of the denominator, which tells us that we do not have any horizontal asymptotes. Now, since the degree of the numerator is 1 more than the degree of the denominator, we do have what's called a slant or an oblique asymptote. And once again, that's because the degree of the numerator is 1 more than the degree of the denominator. I'm going to abbreviate slant asymptotes as SA. And in order for us to find the equation of this asymptote, we need to use division. We are going to divide the numerator by the denominator. So setting up my long division. In this case, I could use synthetic division because I'm dividing by a linear factor, but that's not always the case, that this factor is linear, so I'll just go ahead and go through the motions of the long division here. Feel free to pause this and double check and make sure you divide correctly and you don't make any sign errors. But when we do divide, we get a quotient of x minus 1 and a remainder of negative 8. But it's our quotient that is going to give us the equation of our asymptote, because our remainder will actually go to 0 as x goes to positive or negative infinity. So we're plotting the line y equals x minus 1. So again, we're just taking that asymptote, setting y equals, and going ahead and graphing that. So it means I have a y-intercept at negative 1, positive 1 slope, so up 1, 1 to the right, up 1, 1 to the right. And once again, I'm drawing a dashed line here. And this is the line that my function will follow as x goes to positive infinity. My function will skim along this line. As x goes to negative infinity, it'll skim along this line. Okay, so finally we just need to find the behavior near the vertical asymptotes. So we only have one vertical asymptote here, so we'll see what happens as x approaches 3 from the left and approaches 3 from the right. As we approach 3 from the left, I am positive, but not positive enough to make this term positive, so I have a negative here. Positive plus 1 will be positive. And as I'm close to 3, but a little bit smaller, this is going to be a negative. So my signs for that case are negative, positive over negative. 2 negatives means that overall the function is positive. As I approach 3 from the right-hand side here, a little bit bigger than 3, this term will be negative, this term will be positive, and if I'm a little bit bigger than 3, this will be positive as well. So I have one negative sign, which means overall it'll be negative. So now we can go ahead and sketch. So this slant asymptote is going to be what happens as x goes away from the origin. So as x is going to negative infinity, my function is going to follow along this line. But as I approach my vertical asymptote, from what I've calculated, my function is going to positive infinity. And I just need to pass through my 2 intercepts that I have found. On the other side, as I approach positive 3 from the right, my function is going to go to negative infinity, so it's going down. I need to hit this x-intercept, and then this function is going to come up, but then start to skim along this slant asymptote here. So just forgive the crudeness of my drawing here. Again, it's just a sketch, so we're kind of putting things together as we go along. This will be a prettier looking curve than that, but it's going to go to negative infinity as I get closer to positive 3 from the right side, and it's going to skim along this diagonal line as x goes to positive infinity, where it moves out to the right here. Okay, I hope you enjoyed your example on graphing rational functions using asymptotes and intercepts.